We saw how to convert polar coordinates to rectangular coordinates in the previous video. Now we will do the other way around. From rectangular, that is x and y values, we will come to polar. Now, let's look over here. The same figure, but we will be given with x and y and you need to get r and theta. So this is what we require. Again, we will have to use basic trigonometry, and knowing that this is a this is a right angle, we can use the Pythagoras theorem. So what does the Pythagoras theorem say? Hypotenuse, that is the square of the hypotenuse, r square, is equal to the sum of the squares of the other two sides. That is, square the one side plus the other side, you will get the answer. You do not want r squared, you need just r. So square root on both the sides will give you r. This cancels. So r equals square root x squared plus y squared. This is fine. What about theta now? How do we connect theta and the opposite and adjacent side? You must remember it is tan theta that gives you opposite, that is y divided by adjacent x. But you don't want tan theta, you just want the theta value. So take tan to the other side, it becomes tan inverse. Okay, tan inverse, or it's not taking to the other side, it's basically multiplying tan inverse on both the sides. Over here it will be cancelled and over here it will remain. So it's tan inverse y by x. So what is the answer? It is theta equals to tan inverse y by x. But there is a condition in this case. So whenever we have negative x values, so if it is greater than greater than 0 x values, that is positive, say it's 0 0.5, 1, 2, and so on, you have to just use this formula, tan inverse y by x. But what if it is negative value, x is less than 0, it's like this, -1, -2, or so on, then you need to use tan inverse y by x plus 180 degrees, okay? Or pi means 180 degrees. So this is the thing. This is very important. Now let's see a few problems. If you remember this formula, these two formula, but remember theta has two formulas based on the x value. It is very, very simple. Now over here, we have find two pairs of polar coordinates dimension to over here for each point with given rectangular coordinates. The rectangular coordinates are x value of 1 and y value of minus root 3. What do you do now? All you need to do is write the given x is equal to 1, y is equal to minus root 3. Then see the x value. X value is positive, so it's fine. Use the simple formulas. It is r is root of x square plus y square and theta is tan inverse y by x. All you need to do is substitute over here and solve. So look over here, x is greater than 0, so it's just this much. Don't add 180. Now let's solve it over here. So it is square root x square value is 1 square plus, whenever you have negative, please use the brackets. It will be much easier and you'll get the correct answer. So you close the bracket, square it. The answer is 2. Okay, our radius value or the distance is 2. What about the theta angle? It is tan inverse shift and tan minus root 3 divided by, sorry, this is root 3 divided by 1, close the bracket. The answer is minus 60 degrees. So now they are mentioned two pairs, so you can use minus 60 and you can find the coterminal as well. So it depends on the option how much coordinates they have given. So one thing is, just find one of the angle. This is more than enough. You found 2, radius is 2, minus 60, it's more than enough. This is a correct answer. And then, multiple representation of this polar coordinates, isn't it? You can represent this in 3 other different ways. You can find the coterminal angle over here. You can use negative and add 180 and subtract 180. So you can write any of the answers. So it depends on the options, or if you're writing exam, just write 2. It's more than enough. So over here in this case, they have given two angles. Why? Because minus 60 is one of the correct angle, 2 is the radius. How do you find this? At 360, you will get the answer. That is the coterminal angle of 300, a coterminal angle of minus 60 degrees. So in terms of pi, you can write, in terms of radians, you can write it like this. I'll show you how to convert degree to radian. We know radian to degree is very simple. Wherever there is pi, put 180 degree. I'll show this. For example, minus, instead of pi, I put 180 divided by 3. You'll get the answer. We have done this many times before. But what about the other way around? It's again very simple. Whatever degree you have, just divided by 180. That's it. Now you will get 1 minus 1 by 3. But just remember, in the numerator, you have to add pi. So it is minus pi by 3. Let's even do for the 300. So all you need to do is 300 divided by 180. Now it is 5 by 3, but remember to add pi over here in the numerator. It is 5 pi by 3. So in the polar coordinates, you can write 2 comma minus 60 in degrees or minus pi by 3. Here 2 comma 300 or pi by 3. It's up to you. So this is the answer. Similarly, we will do one more problem. Over here, there's a figure to, this is optional, but there's one more answer question for you. I would encourage you to pause the video now, try it by yourself. Please note, x is negative, so it changes. So please do try it by yourself. I hope you paused the video and at least tried it a bit. Now we will solve it together. Here we need to analyze this given it is x is minus 3, y is 6. Now substitute the formula and solve. Over here r equals root of x square plus y square. X and y are given. Substitute. Same thing over here, tan inverse y by x. Remember, y is first. Top 6 by minus 3. This pi is very, very important because it's a negative x value. Sorry. Okay, now we will just solve this. So square root of, use the bracket, minus 3 the whole square plus 6 square equals 3 root 5. And over here you need to use shift and tan inverse. So 6 divided by minus 3. It's not over. If you press equal to, this is not the correct answer. You need to plus 180 degree. Why? Because pi is 180 degrees. You're getting 116. Now look over here. Why I'm not adding directly pi? Because your default mode of the calculator is in degrees. So always use degrees. So don't need to change the mode and everything because you can always convert to degrees. Just stick to degrees. Okay. So the answer is 116 degrees and r is 3 root 5. Now you can convert this to radians. We just now saw all you need to do is divide it by 180 and then you can convert it is approximated 0.647 is 65 pi. So this is the thing. Now sometimes what happens is in your textbook you may have noticed instead of pi they multiply it. See, now instead of writing it like this, they multiply it and do this. 2.05 would be 2.04 is the answer. Theta is 2.04 radian. It's up to you. These are just conversions. I've written all this just for you to understand. You can use this or use this. All the 3 degrees are correct because all the 3 degrees mean the same thing, but the most important thing is it depends on your options. If this is coming for MCQ in the online exam, you will have 4 options. See the correct option. Now over here, this is very important and crucial. You've got one polar coordinate, 3 root 5 comma 116.56 degrees. Now I would want you to find the other 3. Try this by yourself. It's not compulsory, but just try to find it. See, the first one, I'll anyways tell it over here now. The first one over here is very easy. The same R, but only thing is find the coterminal. So subtract 360, you will find another degree. So 116 is somewhere over here. Now this is 116 degrees. If you go in the other side, it will be minus 200 and something. So this is one way. The other way would be, instead of going to this, go to this angle over here and use minus radius, minus r. So you will come to the same point. This is called multiple representation. We have studied multiple representation in the lesson 1. So I would kindly ask you to go back to the lesson 1, video 3, I believe, which discusses multiple representation of polar coordinates. It is very important. Why? It's easy to find one radius and one theta, okay, from the calculator. It may be difficult to find the other values directly, so use the multiple representation information, whatever was done before, and then easily solve it up. So that is the thing. This is the answer. You can use the multiple representation over here and solve it. And now quickly let us recall both of these. See, over here they have given convert to polar coordinate, and over here from rectangular to polar. I won't do this, but I'll just show you how to be done. So if you want to find the over here, the rectangular coordinates from the polar, all you need to use is this formula: x is equal to r cos theta, y is r sin theta. Substitute what is x, what is r, phi, and theta is 295. Same way r and theta in sine. Solve, you will get the rectangular coordinates. X is 2.11, y is minus 4.53. Same thing with polar coordinates. Use the formulas which you just now saw. X is greater than 0, so use this theta formula. Substitute over here. X is 3, y is r, and tan inverse of 7 by 3. Put it in the calculator. Class. This is it. So this is how you can easily convert rectangular to polar, polar to rectangular, or rectangular to polar. Okay, this gives both the formulas. We just remember these 4 formulas and you can convert to anything.